Welcome to Advanced Data Analysis 1 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, I'll help get us jump-started into our first in-class assignment. So here we are at the course webpage, and I'm going to scroll down to the timetable where we have the 01A medical records. So this is the first assignment of the first week, and I'm going to download this file by right-clicking and saying Save Link As. I'm going to drop it onto my junk space of my desktop. Without dragging my desktop somewhere it doesn't belong. Alright, so downloaded that file, and I'm going to go over to RStudio now, which I've opened and done nothing else to. Alright, so let's open that file we just downloaded. There we go. And I'm going to compile it so we can look at the output as we discuss the input. Okay, and as usual I need to resize it to fit inside the recording window. So here's the medical records assignment. In our ADA1 class, the current author is anonymous. All of our peer-reviewed assignments will need to be anonymous. That's because to reduce bias, so that you don't know whose assignments you're grading and no one knows that they're grading your assignment. So that's the default there. We've got a date here, and it says this is a template for the assignment in the rubric at the bottom of the page. So let's go down and take a look at the bottom of the page. We're scrolling past the data section and the code book section, which we will be filling in a moment. So here's the assignment. Actually, I'm going to open this up in a browser so that I can zoom in a little bit, make this easier to read. So from Passion-Driven Statistics, Chapter 3, I've slightly modified this assignment for our purposes. So although in your project you will be working with previously collected data, that is, throughout the course you're going to select a data set, such as from the Adolescent Health database or another large database, and you're going to work with that data to answer questions through the semester. So in this case we're going to think about how to put data together in a well-documented way so that other people can use it without a lot of confusion. If you've been in my position for the last 15 years or so doing collaborating with other people, or even looking at your peers when they collect data, it can sometimes be not clear about what rows and columns mean and things like that. So we're going to try to put something together that's really well self-documented. All right, so it's important to understand what data look like and how it's entered. So here's our scenario. Imagine collecting medical records for 5 patients seeking treatment in a hospital emergency room. Points for each component are indicated in parentheses. So we have 6 things that we want to do in this assignment, and these are the 6 aspects that you want to make sure you fulfill during this assignment, and when you assess other people, these are the 6 qualities you'll assess them with, and obviously those are the 6 that you'll be assessed with. So this rubric is making it very clear about what the expectations are and what's required to get 10 points, which is the total number of points. So we're going to collect 5 patients, and we're going to think of 4 variables. So this is off the top of your head that need to be recorded when these patients come into the emergency room. Okay? One of the variables should be a unique identifier. At least one should be a quantitative variable, something that's either discrete or continuous, something numeric. And the other should be a categorical variable. Okay? Something that takes categories where the categories don't necessarily have a numeric meaning. Then we'll, once we've decided what those 4 variables are, then we should select a brief name for each of them. So for example, if you had an identifier variable, your variable name could be identifier or ID or something like that. Then determine the variable type and the range admissible for recording each variable. So for example, the variable type for an identifier is a categorical variable. It's not continuous. It doesn't make sense to subtract patient 3 from patient 1, for example. Then we want to list the variable names, labels, types, and response codes in the codebook area, which is above. We'll take a look at that in a moment. And once we've created a codebook, then we will make up data for these 5 patients for those 4 variables. And then we'll compile this into this document here, but all your results will be up top. So let's go to R and take a look at what created that document. Here we are at the top. Here's the YAML, that header that has all the document class information in it. We have the title of the document, the author was anonymous, the date, and then output HTML document. Here's the template for assigning this rubric. It says delete this line at the end here. We won't need that for our assignment, so I'm going to go ahead and delete that line. Here's the data area, and we know this is a header because it starts with a pound sign. Here's the codebook area, and I've given you at least 3 options depending on what's going to work better for you. So let's go back to the browser window, and I'll scroll up to the very top. There's the data area. I'll scroll down a little bit more. Here's our codebook area. All right, so in italics, right? Remember italics, if I go back to R, I've got single asterisks to begin and end that line, and that's the way to create italics. All right, so I'm just reinforcing some of the things we've seen before. So we've got 3 ways that we can create a codebook. The first is a table. Okay, we can select what the variable is, what the label is, the type of variable, the values it takes. Okay, this first variable is a categorical variable that takes values 0 and 1, indicating type 1 and type 2. Maybe another way to have coded that would be a 1 and a 2 for type 1 and type 2. The second variable is continuous, and it takes ranges between 0 and 120 inclusive. That would be a good range for ages of people in years, for example. Let's take a look at what it took to create that table in R. All right, so here is the table. I've highlighted that area. So we have a header line, and notice each column is separated by a pipe. This pipe, the vertical symbol, is the shift / key above your enter key. And that's called a pipe. The second row here is what separates the header row from the rest of the table. And so we have hyphens separated by pipes for each column. So here we have 5 columns. Okay. Notice our header row only had 4 columns, but we need 5 because our first data row has 5 columns. It has the variable name, has the variable description, has the type of variable, it has 2 values, the first value and the second value and what it means. And then we have the second data row. It turns out from my experimentation that the number of columns that appear in the table depends on the number of columns defined in this row that separates the header from the data rows. In fact, if we remove those 2 characters, okay, oops, didn't mean to do that. Can I do a redo? Oh boy. Don't start just mashing every key you can, Eric. All right, here we go. So this is the row we care about. I'm going to remove these last 2 characters to remove the last column, and I'll recompile. Notice, here's the table, and we only have 4 columns. We've lost the last column on that first data row. We don't have 1 equals type 2 at the end. If we come back and add that back in, pipe hyphen, let's get rid of all that. Okay, and compile. We've got it back. Okay, so if you are missing columns, it's because you don't have enough columns defined in that row. All right, and that is pretty much what this whole next section is intended to say. So you can go ahead and read that on your own. The second way you can define your code book is using a list. So let's take a look at this list. For each variable, you can define the type, or a description for the variable, the type, and then the values it takes. Piece of cake. And we've seen how to do those lists in a previous video, and they're over here in the help as well. Recall that this help is available by going to help and mark down quick reference. All right, the third method is to use a verbatim block or a code block to create this list. This is actually the method I prefer, but I'm a very text-based Turing machine user. So here's what the text block looks like. I've just defined what my variable is, and then I've indented the remaining sections. So if we go over to R, I have a triple left single quote to start and to end the block, and everything inside appears pre-formatted or in verbatim, meaning what you see is what you get. A WYSIWYG. So that's it. That's the introduction to, that's most of it. The last part is data. So once you've defined what your variables are, then we need to put data in. So I'm going to scroll up to the top, and here is our data section. I'll go over to the browser and page up. Here's our data table. What does data look like? Data looks like this. Each column is a variable. So variable 1, variable 2, variable 3. You'll have a fourth column here for a fourth variable. And then each row is an observation. So you'll have 5 data rows, 1 for each patient. So you'll have an ID number, maybe you'll have the person's age, etc. Okay? And you'll put that into a table. If we go over to R, notice that in this table I've got lots of hyphens. Okay? It doesn't matter how many hyphens. We saw before in the code book that it really just requires 1 hyphen. Okay? So you can, I recommend doing something very simple, like down below where we did the code book, but you can format it like this so it looks nice in the code as well as in the output. Really, the output is the thing that matters. So go ahead and fill in your data, compile it, take a look at your output, remove anything you don't need, make sure that your name is anonymous, and follow the instructions in class to upload your assignment to CrowdGrader. And then in class we will actually grade each other's assignments to get a feel for what this looks like. All right, that's been the Medical Records assignment for Advanced Data Analysis 1.